Welcome back to Made Up of Wires. We're decompiling Castlevania Symphony of the Night. You can see the shop open above me. We're going to look at that today. If you want to know more about the Castlevania Symphony of the Night decompilation project, you can go to soten.z.dev where you can learn more. And you can find a link to Discord. A lot of people, I think, have found the project through the stream and through the YouTube. I'm happy to see, and things are moving quick. You can also find a link to GitHub, and you can see the status of several of the overlays that we've been working on. We had been doing some stuff in the outer wall, and there's still more to do in the outer wall, and stuff that I haven't had a chance to send a PR out for yet, but need to get cleaned up and send that out. And then we're going to be looking at lib, which is growing slowly but steadily, and we have a few things there. Porting the chair over and making sure that it worked there as well as the outer wall. We'll keep going on that, but I think today we are going to focus on the shop to start, and then we can move on from there. Coincidentally or not, I don't know, but GitHub user Alchar, also known as alias Alexander Sharon. Knowingly or not, I'm not sure, based on comments that were in the PR, has decompiled the main shop entity, or like this, the thing that drives this menu. So that has been done. I will share my notes, which are minimal at best. So Mozilla was on yesterday, and he knew exactly the memory location. He has notes from doing mods for the randomizer community. He has notes that happen to have the inventory list address, which we were able to pull. And then from that inventory list address, I was able to find this 29C4 function, and that's the one we're going to look at first. And that function is called by this 2BE4 function, which comes slightly after it in the file. And this is the one that Alchar has already decompiled. Apparently it was the longest file in the in this overlay. We might go back and reference that to get additional details. And so what we're working on is a helper function that looks at the list of inventory items. And I think we'll go through and decompile that list as well, so that we can get all the data and maybe map the appropriate items, which actually we may find some items that haven't been enumerated yet, which will be neat. I haven't done any of this. I was working on the CD BIOS stuff yesterday and spent a good portion of my night doing that, and got a bunch of that checked in as well. There were some interesting things with binary coded decimal, which is used a lot in the CD ISO 8661 spec. Okay, so we're going to look at source, assembly. First, we're going to pull the data, and then I'm also going to open the assembly for this function. And then we can look at, before we get going with decompiling, let's look at the caller of this function, which is the main driving function for the shop. And it's a doozy. It's quite a big function. We see some debug text that's included in the PSP version, but not otherwise. Step 0 in our state machine is allocating the primitive. Our texture page is different between the two. I'm not sure. That would be interesting to see if there's an obvious difference in the texture, or if there's maybe just textures that weren't included because they weren't used in the PSP version, but the texture index is different. So that state 0 is setting up all the primitives. State 1 then is, so are we in a cutscene? This is going through, there's 64 slots, it looks like, in this menu. So my guess is that there's 64 items. And then we're looking at different equipment slots throughout. And here's the infamous 99 minus break that we can do. So when you're selling items, you can sell an item that you don't have, and if it wraps around, it will max back at 99. And so we might be able to find that the code for that glitch. That'd be kind of a fun thing to fix. Just a monster though of a state machine. So let's go back to the one we are going to decompile. This is a much simpler function, and I'm assuming that it's going to take inventory. Let's look for it again and see where it's used. It's only called once, and basically if the pointer that it returns hasn't been set yet, we're going to set it, and that's it. So let's see what it does. We're going to use decomp.me, like most days. I did get a lead. I posted this in the Symphony of the Night decomp Discord yesterday regarding why these, if anybody knew what was going on with these addresses, that may or may not help. I did actually do some looking here as well and rename these A and B variables based on other functions that were decompiled. SozuD pointed out that the alarm object probably is a struct, and there likely are fields afterwards that are part of that same struct. And so accessing that through struct instead of directly by symbol name may change how that works. And so that might be something to look at later this week. But for now, I'm going to save this. And actually, in the background, I'm going to kill my, since I know that now, I'm going to kill my what do you call it? Permuter. Taking up all my electricity and bandwidth. Not bandwidth. CPU cycles. All right, so we'll paste our assembly in for this function. So we know some things about the data. Sometimes I like to pull data in when I know it's a function that's going to be referencing big arrays, because then I can kind of slice that up as I'm going through and decompiling. Not a terribly long function. And so the things that I'm going to be looking out for is when we have these different addresses, are there offsets that are so close together that they're likely the same thing? And let's start by looking at the one address that I was interested in. Which is this 134C. So I believe Mozilla said that this was either an 8 or 10 byte structure and then arrays into that. We can see if we can tell what that might be. So we're taking a reference to that address. M2C, when it's decompiling this, doesn't know that it's an array yet, and we can tell it it's an array, but we need to know what the size of each of the structures in that array is. So let's follow varus1 and spin around for a while. There we go. And there's a couple things I want to see. So in this case, varus1, it's getting moved to varus2, and then we're adding 8 to it. So we have a structure of 8 bytes that we're going to be incrementing along. So we know that that this 34C is going to be an 8-byte structure. And I'm going to do one more thing. I'm going to look for varus1 and see if it's always being accessed by byte. Because that will also be a good indicator of what and how this is being used. I'm not seeing a direct reference to it. Here's our references. So here's an offset of 4. I don't see a lot of other references there. Some of these other ones, if they're close by, they may be related. But let's start with a struct, and we'll call this inventory item. And all we know so far is that it has 8 bytes, and we don't know what those bytes are. So I'm just going to call them all unsigned 8s for now. And then we have an array of these. And we can move this into the context. And then get a new decompile, and maybe we'll get some additional types. Maybe we'll get something else. But hopefully, varus1 now, we don't quite have something that is going to be usable, and so we're going to have to keep going. This might actually, since the library is, we're pulling the PSP version as well, I might actually grab the PSP version. That'll be a little easier to decompile, and should be relatively similar. Hopefully the same. So let me do that. So I need to find a unique value that I think will only be in this function and nothing else, but also something that's not specific to the PlayStation. So none of the addresses are on the table. There's some masking in here. Let's look at this hex 86. That's a unique enough value, I think. So I'm going to look at ASM PSP, and we have quite a few. I'm going to be looking for ones that are at the end of this line. For that, we only have one function. Let me double check that that's what this is. 59. We won't know for sure here. Though this compiling, it's a little trickier to find. There's a sign less than immediate. So let's look here to see if that same thing exists. So I just grepped for the 80, hex 86. This does not look like the same thing. So let's look for 85. It's possible as well that that the 86 is being used in a different way. But we could look for 85 as well. Let's say we'll start with that. Can't start with 85. We can say not a star. Sorry, not a D. And we want to see if there's a function that is less than. This is the closest thing I see here in this 1138. And this is we're already here. We're already here. Is this possibly the same function? I just missed it. So we have comparisons 86, 81, 80. I don't think that this is it. Let's see what else we have. We do have a relative or a registered jump in the function that we're looking at. It's possible that this is it, and I'm just being silly and biased. Let's pull it and see what's the worst that can happen. So here I want to create a new PSP scratch. We should be able to tell pretty quickly if this looks similar. I'm going to grab these this struct inventory item struct that I made and throw it in the context here. And we should get a sense now of whether or not this is the same. The top actually, it does look somewhat similar-ish. We have a switch here that isn't in the original. Maybe it is in the original, but it wasn't a switch. And that's what it was. It wasn't a switch. All right, so despite looking very different and having a very different structure, I do think that this is, I'm going to go out on a limb and say it's the same one. The addresses are much grosser, unfortunately. At least I don't like them. I can't read them as well as the 8,000 prefixed addresses. So the things that we need to figure out now are what is the inventory on the PSP side. Unfortunately, the inventory data I find to be relatively opaque. If it's the same structure, let's see what data it is. What is our address? If it's there's two things that could happen. Why is this not here? where did this go? I must have just been looking at something wrong. All right, so here is our data. So on the PlayStation side, this is all coming in as just individual bytes. It's possible that it's coming in a different way. So let's look for like 9F. 9F is a fairly unique number, and see if that shows up in any of the data. Evening, dig down deep. Evening, eldritch. Afternoon. Morning. We're looking at the shop inventory helper function and trying to find the equivalent on the PSP. So here we have, for data, there's one instance with F4 as a byte, so it looked like that was a good choice. Whether or not this is also the inventory data for the PSP, I don't know. But let's look at that address and see if it is the same function that was pulled already. This is being referenced by the CFCO function, which is not what I pulled. Also a table with also as a jump table. I'm less convinced that this is it. So the PSP, when M2 or when Splat comes through and splits that file, it might see that that data is being referenced as bytes and split it into bytes like it did on the PlayStation side. It might determine it can't decide what it is, and then treats it just as words or treats it as shorts. That's a little harder to determine. And so what I wanted to do is find that similar data. Usually this should be in about the same layout, so we should have something with 3 pointers and then our shop data. This doesn't look like that. So let's keep looking. And I was looking for OXF4. It could be that the shop data also is just mixed in with a bunch of this other stuff, in which case we could look for something on a boundary. So these are going to come in byte order. So O5FF0000 would be the word. And I don't see that yet. There we go. That looks more promising. And it's right at a boundary that was discovered by Splat. So now we can find the function that references that and see if it was the correct function, and it was. I did have the correct function the first time. So the structure of this is very different. MetroWorks is compiling this as, or it's a switch driving the function, and that's how MetroWorks compiles it. But GCC, when it compiles it, it says, I don't need a switch, I'm just going to use standard conditionals and not have a jump table outside of it. So that's something to keep in mind as going through this, while going through it. And now we know what the offset, or the address for the inventory table is, which is here. And we can give it the inventory table type. On the PlayStation, Eldritch is asking, what memory ranges are we looking at? Give me 1 second to grab this type. So another thing to point out is decomp.me doesn't know anything about the data. It doesn't have access to any of that. So when we have addresses, it just knows how they're being accessed, words and other things like that. So in, no, it's not here. Why, where did that go? Oh, this page must have reloaded. Give me 1 second. Oh, no, this is the wrong one. So 801, 813, 4C is the inventory table. And Mozilla was on yesterday and pointed that out. Yep. Yeah, that is the shop inventory. All right, so let's grab a fresh decompile there. Do you happen to know the layout of that offhand? Eldritch? Yeah. Mozilla is trying to remember what it was. We'll figure it out going through, but if you happen to know the byte order, we can get through that much quicker, get nicer names. And that's fine if you don't have that handy. So this 8018.150 appears to be another byte array. Nope, a short array, excuse me. So temp A1 is being multiplied by 2. So it looks like we have a 2-byte array. So should we fix that then? Yeah, don't spend too much time on it if it's not readily available. And then our last array here is the same thing, scaled by 2. So that will be a short array as well, whether it's signed or unsigned. We'll figure that out. All right, and now a few others. We have some negative offsets here, which is always a pain. These are coming from yeah, this is over optimized GCC. So it's coming from the E field, so 1, 2, 3, 4, 5, the fifth offset, then minus 3 from that. So RA2 is going to be an inventory item as well, just with an odd offset. Yeah, I got that part. So I'm just going to, this would be around B, either C or B. The compiler will tell us in a little bit. Minus 2 from C is going to be DC. From E. And this will be E. I have a few more of these. It looks like these values are being copied. So var A3. That also is going to be, oh, maybe not an inventory item. It looks like it is, though. All right, so we have something, and we can take this over as well to the PSP side and get something here as well. Maybe not something as valuable because we know that there is going to be a switch coming. And PSP helpfully points out some of the reference errors that GCC is so happy to just allow. So much less matchy on that side. So let's go back to the PlayStation side. And as I'm going through this, I'm going to be doing it with an eye towards turning this into a switch statement. So temp A0 is our driver here. It comes from var v1, which comes from the B field, which is actually, it looks like the what currently we're calling G. And let me look at what I want to see is if any of these numbers are looking familiar yet. So this may be ordering. I'll pull that data in a second after we get through this top part. I'm not sure if I should base this off go with the PSP version or the PlayStation version. The PSP version really does have a much nicer structure. I think I'm going to do that and go with the PSP variables, which is going to make porting it back to the PlayStation a little bit painful, but not the worst. The major advantage here is that some of these odd negative offsets likely won't exist. So we do need to fix a few things, and those we can steal from the PlayStation decomp. So this function call here is to one of the G API functions, which is the time attack controller, so we'll just steal that line. This is going to be a little more piecemeal than I normally do it, but I think that should be, I think it'll work out. And then we have a few of these others that, these look like they were Science 16 arrays. All right, so thank you, Eldritch. So we have 0, 0, 0, 0, so 2 bytes of nothing, it sounds like. Item index, 1 byte, and then another nothing, and then, so we have, that's, and then 2 bytes for the price, I'm guessing. Right, that makes sense. 2, 3, 4, 5, 6, yeah, 2 bytes for the price. So let's do that as well. I'm going to make these arrays and then move all this into the context. Some of these types may be wrong. I'll separate them out here, but we'll say unsigned 16 had a and I missed one somewhere, right? 2, 4, 6. 4 bytes for the price? Let's look at that data again. All right, so Eldritch is saying the first entry after Fuel to Open is potion 00009F 00. So 9F is the hex ID. Let's find that in this list. All right, so that's the second entry in this list, and that is what we see. And got it. So let me go back here. So we have unsigned 16 for price, and then another 2 bytes, it looks like, of padding. And that gets us 8 bytes. Okay, I think that works. So let's get a new decomp. Maybe this one will compile. All the notes that you guys have kept. Did you ever think that they would aid a stream? Maybe. All right, so there's a few things that I need to go back and fix again. I think that's the last time I'm going to run M2C on that. So Eldritch is saying there may be a quantity marker in there. If that's the case, then there's nothing preventing me from backing that out. And actually looking at this a little closer, my guess is that the last value is probably a 32-bit value. Because some of the prices are going to be higher than 16,000. So let me fix that before going any further. And then get the decomp. Yeah, and we can dump some of that, go through and buy some things and dump and see if this list changes or not. I actually don't know if this list is mutable. This may just be, I don't know. We'll see. We'll see what happens here. All right. So for the millionth time going over here, stealing that line from the PlayStation side. Get rid of this. So this is a symbol that we should map it actually, and maybe I'll take the time to do that since I'm here anyway. This is a symbol that should be mapped on the PSP. So as long as I'm distracted, let's grab that. So I think that can just be part of PSP EU, not. So now if I have to dump that again, that symbol will be correct. It's the little things. So we can get rid of this. Later, Eldritch. Thanks for stopping by. Thanks for the info. Really appreciate it. For those watching on YouTube, or maybe those in the stream who haven't been here recently, Eldritch does a lot in the randomizer community and running Soten.fun. No, Soten.fun is which one is the Soten.fun is our wiki that Biz Murphy set up. Soten.io. Yes? Yes. If you're not familiar with Soten.io, you can get patches for Symphony of the Night and choose different things, different presets, tournament modes, randomize items. One of the cool things that they've been working on is adding new spells. When I was watching Mozzilla's stream over the weekend, he added a spell that allows you to put a block underneath you. So when you jump, you can stick a block underneath you and basically stay at that location. So going up one of the bell towers, for example, becomes a much easier endeavor. And those guys are taking the CD offsets and the assembly and figuring all this out from that data, looking in debuggers like we do, and just the way that they work is amazing to me, very awe-inspiring. All right, so we need to fix these compile errors. Today's a slow one. And figure these out. So we don't know what this 680 is yet. Let's go and see if we can find this PSP data. So this is the end of the list. No, sorry, this is the beginning of the list. 680, why? So Varus1, it knows that it is pointing to a inventory list, or an inventory item list. Why is Varus1? Oh, it is. It is. Let's look at the next one, this D40. That is not in this file. And it should be relatively close. It's BSS. So BSS is uninitialized data. Over here. So all we know with that is that we might know the approximate shape and size, but we also might not know anything. Come on. Yeah, so we have 200 bytes of space. I'm going to assume that this is inventory items as well, and that we're copying this list over. Maybe. Let's start with that assumption, and then see where that goes. And we can look at Varus2 and try to get an idea here of how it's used. So the big thing here is price, I think, is coming from a different offset. I didn't put offsets here, but that might make this easier to read. The item code may be 16 bits. This is a poorly packed structure. It's somewhat interesting to see when great care is taken to pack these efficiently and when not. So this does look like it is the same inventory item struct shape. So I am going to do that, and then I'm going to give this that same type. And now we need to fix these offsets. The fact that this first field is being read means it isn't just a pad, it is something else. So we'll have to figure that out. Item code, we're gonna have to rename that to match. Item ID probably is the better name. And then this was price. And it is being loaded as a 16-bit value. So the item code is 16 as well. And then that makes more sense from a struct packing perspective. So we have one more on line 42, and then we should have something that's compiling, and we can see where we are. So virus 0 is being used up here, it looks like, without being initialized. We'll see if that has any effect. Often that's just bugs because either they were ignoring these errors or it was code from the PlayStation side where they weren't looking at those errors, and so they just didn't deal with them when it was ported. Sometimes we see errors like that fixed between different versions. So by the time it got to the PSP, it had already gone through the Xbox 360. So there'd been, and to a certain extent, it had gone through the Saturn as well. So it had gone through several compilers by the time it got to this point. And there are still warnings like that from time to time, but not always. All right, so the first issue that we have is here on line 15, where virus 3 looks like it's being incremented. And this likely was an optimization for on the GCC side. So when we increment here, this is the first time that it could have been incremented. So GCC just says it's going to be 1. I can do the assignment. I don't need to worry about the math. So I think that's what was happening there. RS3. There's a bunch of masking here, which tells me that this is the wrong type. But what type should it be? Not quite sure yet. I'll leave it as sign 32. But there's some additional issue with this masking here. Oh, I'm looking at the wrong line here. So we have a mask. We can get rid of that by just getting rid of the 0 check. And that will get rid of that. There is an additional mask here that I'm not sure where that's coming from. It seems like it should be here. And maybe we get that if we force the load. Otherwise, we'll come back to that and see if we can figure out what might be causing that. I could try one other thing, make this a unsigned 16. That fixes it. Okay. So the rest of these are going to be just increments on this value, and because of the type and because of the implicit conversion between types and registers and things like that, MetroWorks adds all this additional stuff, but it's not anything that we actually need to produce code for. And likewise, these are all implicit. So it's likely that these are, and I think we actually get those on some of them we get on the PlayStation side, what the symbols are. They probably are all related to various symbols like this. We don't need the mask there. We do need the and one. All right, so that is coming together. There probably is more here that we need to resolve. These symbols, though, have been mapped between the two versions of the game, PSP and PlayStation. Anytime there's no underscore between them, I guess it could come from DRA. We'll see about those in a bit. And now I think we're down to the main loop almost. Get rid of this and get rid of, make that an increment. We're missing one. Missing one mask here. I'm not sure where that is coming from yet. So the mask is on S3. S3 is... oh, it was S0 on the PlayStation side. There we go. All right, so the next thing is our loop. We're setting var S6 and var S3. So what was var S3 along the way, and how are we using this later on? Down below, we're comparing it to, I believe, how many items. Basically, it's an item count, and we're checking if one is larger than the other. Maybe this is related to like things that Alucard is currently holding, but it is a little bit different because there's like things about finishing the game in there too. We'll see. We'll see what that is. So our switch is going to be just on var S0, which is the item code. I think we can get rid of all of this. We can call var S0 the item code. And just make sure that there isn't a different S0. I don't see one. And another name is probably item ID for that. Might be better. And this is being masked though as a byte. So let's change that back over here. And we can see if the alignment still works out. It's possible that we don't need the pad, the explicit pad in there. I am going to do just a spot check on the PlayStation side. So taking this new version of this structure over, as well as the code as it is. All of our symbols are going to be wrong. I will need those symbols over here to compile. And those are probably worth putting just up top in general. One more I missed. All right, so not super close yet on the PlayStation side. I do think that this will come together though. I'm not too concerned. The big thing is, because the control structure is different, because the control structure is different, how GCC optimizes it is going to be different. And so GCC has taken the position that I can do a bunch of tricks with normal conditionals and just numeric comparison that we might not be seeing here yet. And so we'll keep going and then figure out if that's something that can work. All right, so I think that this is a fall through. We'll deal with that in just a little bit, but I'm pretty sure that we can treat that as a fall through. Any temp v0 is unnecessary. So this, another hint that this is not a normal switch or a switch that was pulled out into a jump table is this irregular. That means M2C has identified it as a switch, and but it's implemented as just normal conditional logic. And so what we want to see as we're going through is whether or not the logic, so we have our big jump table logic here, are these happening in the order that we're seeing them here? And as long as they are, then there's nothing that we need to worry about. Some of these are masked in a way that we can tell that they are just Boolean operations. So here we're breaking. A few of these cases were we're going down to block 45, and what I think is happening here is that this effectively is a fall through in the switch, and the other cases are breaks. So if we hit one of those cases, we're going to break out of the switch, which would take us to the end of this else, which would take us here. And so this whole section down here below is possibly not part of the switch either. We'll see about that as we get through it. So this is breaking us out of the switch. Yes. So this is after the switch. Yep. Okay. I'm happy with that. So our so after each of these, we need a break, and then instead of the go-to, we're just gonna let these fall through. And same with this, and that's going to be the end of that statement. And then we can get rid of this block 45. Because it is not being used anymore. And then our loop here, go to loop 51. If we go way up to the top, this is our loop. And so here we can make this a while loop. And get rid of our go-to. It's possible that this is a for loop. So var s4 looks like our I variable, and we're incrementing it each step along the way. The other thing we have as well is this var s1, which is pointing to our inventory table. So one is the inventory pointer and the other is I. So I think there's only one var s4 here, so I'll call that I lowercase. And then var s1, that will be our inventory pointer. And we don't plus equals 8 that, we just do a plus plus because the structure will take care of the size. So I'm going to move that up and try to write this as a for loop and see if that works out. It might, it might not. doesn't look too bad. There is a mask that is missing. Let's make this a U8 maybe. There we get that mask. And now we're getting closer. Line 72, we have some extra masking. There's going to be a bunch of that needs to be cleaned up because now we have the right data type. So we don't, most of the time, as long as the type is right, the masking isn't necessary. There's a bunch of these that are branching to the wrong place. We'll worry about that in a bit. It looks like some of that is due to unnecessary masking as well. The offset's just wrong. So temp S0 likely is a byte, an unsigned 8. Yeah, maybe not. So here we're taking item code minus hex 81 and then using it as index and masking and masking and masking. One of those may be necessary, but I'm guessing the rest aren't. Let's see. Yeah, it does look like one is necessary. I think we can get rid of this cast, maybe not. Oh, maybe. Let's shift and then mask again. So something not quite right is going on here. That could be, let's look at this 860. We don't know what that is yet. We just know that it's being pulled in actually as an unsigned 16. That might give us some additional masking that we may or may not want. I am going to get rid of these from here since I have them. I think we'll come back to this in a little bit and try to figure out what's going on with the masking there. We haven't implicit mask here that actually was optimized out, which is kind of funny. Another mask here. We probably need one, but not the other. Maybe not either. So this 870 is also unsigned. So these look like lists of items, and we'll have to do some work to figure out what those are. RS3 also looks like it is. We were incrementing these. I thought it was a counter, but it looks like it also is related to items. And so we're just doing a regular check against that. Don't need all the masking. Don't need all the masking down here either. And as we remove that, it's getting closer and closer. We do have, so there was this field in the front. It was called pad. Obviously, it's not a pad because it's being used. We can see that this is being treated as a 16, but it's actually 2 bytes in the front. So we have an unknown 0 and an unknown 1. And we'll get some errors there. And I'm going to take that over to the PlayStation side. PlayStation side may be relatively close to matching, if not completely matching. Because this PSP side is getting very close. RS2 here, this needs to be just a plus plus. RS6 as well. So here we want unknown 0, and here unknown 0 as well. And here we want a plus plus, and RS6 we want a plus plus as well. RS6, where have we used that? So this is a count of something. And we're subtracting 7 from it. I don't know why. We will figure that out along the way. So this is a reasonable pass. I'm going to cast this as a, it might be a signed 16, might be an unsigned 16. What I want to get is the free mask here, and that looks like it works. So var S6 looks like it may be an unsigned 8. And that gives me a bunch of the masking that I was missing there as well. So I think we have most of the data types correct. Not all of them, but many of them. And so we'll see on the PlayStation side if we got something close. Still not super close on the PlayStation side. The PlayStation side is going to be angry because I didn't give it its symbols. So we may have to fix some of the symbols to get that looking a little nicer. So let's do that. The MetroWorks compiler is much kinder to symbols being different. So I'm going to go back the opposite way and start fixing up some of these symbols, targeting the PlayStation. It does look like I made a mistake possibly up here. So since I have started updating that, I'm going to move this over. And so some of the immediate values will start falling away. This does look correct. So we'll keep going on the PlayStation side. So as we switch these symbols, the immediate value symbols will increasingly diverge. So this top one looks like it's castle flags. And I want to see these start converging, but I'm not sure. So, hey Eldritch, good to have you back. Some updates based on what this is doing. So there are 2 fields at the beginning of the inventory item structure. It does look like this code is using them for something. What that is yet, I don't know. The first one is a byte that's being copied for reasons I don't know exactly. And then the item code, I don't think there's anything interesting about that. It's a byte but it's taking up 16 bits for, I think, alignment reasons maybe. It's possible that the other one is too. All right, so what else can we figure out on this PSP side? So it does look like some of these are out of order. I'm guessing that these are in numeric order. That looks correct, and those should start falling out as they're fixed. And that might be what's making GCC cranky as well, as the ordering corrects. Maybe these will as well. Let's see. So now the immediate values here are the location being jumped to. And the only thing wrong here is a mask that is unnecessary. And that's because this type is likely wrong for temp S0. So let's look at that. It's a... So we have an extra mask I can get rid of. Possibly this is happening inline. Oh no, it's being used 2 different places, so that wouldn't be the case. So we have to figure out this masking. Let's try a few things with temp S0. I don't think it's going to be signed, but it may be a larger type. All right, that looks better. And so now what's missing is this subtraction. The item code is being masked first. So S0 is, at this point, is set already. But we don't have any other code that is setting S0. This may not be the same variable down here, and that might be why the registers are off. So when we come down, but it does make sense. So we set the item code, and then all these other things along the way are setting an item code as well, but it's basically a flag and 0FF or some value from these offsets. And so my guess is that maybe the same register was being used, but this is actually a separate variable, and we're missing a 16-bit variable here. So I'm going to add a new 16-bit flag variable, and we need to make sure that regardless of what's happening, that flag is going to be set. And so we can look here and see what our sign less than equal is V1 versus V0, or S1 and S0. S1 is what we need, and it's called S0 on the PSP side. And yeah, we're not setting the right thing. So we need to find where S0 is originally set. And I would guess that it's set somewhere near the top. So around line 58, we're pulling the item code from slot 2, and this is actually reading from offset 1. So we'll have a flag that comes from unknown 1, right? I know that matches. And then our switch is based on that flag. Yeah, we're looking at the shop stuff right now, Mozilla. And item code, I misinterpreted that as I was going through. So this entire switch is based on this flag that doesn't appear to be set. Let me update all these and then see if that makes any more sense. There's this item code though that yeah, I'm doing something wrong along the way. All right, so to catch you up, Mozilla, the inventory item structure at the offset that you gave me looks to be approximately this. 2 fields that we don't know what they are yet. This the second byte is used in this switch, and the switch is the main driver for this function. And going and looking at this second byte, so for every other word, we're looking at we have to yes this is being set. Okay, never mind, I'm dumb. So 05FF, that second field is going to be this. So it is getting set. Okay. It's not always set, but it frequently is. Okay, so that is a field, and it it isn't always 0, so that's good. So let me back this out. There is something else going on here that I'm not sure what it is. I still am going to call this item code, even though it's not the right name. And it's coming from unknown 1. Oh, the second byte. is when something is unlocked. Oh, that'd be great. Mozzilla's going to send notes via Discord, and then we can see if there's any additional information. So the main thing that is at issue now is getting this temp S0 resolved, and that looks like that did it. So if we fall into one of the cases here, we're actually mutating the same variable. It looks like that the switch is being switched on. And now, do those match up? It looks like it does. Weird. Yeah, Sulaco is my Discord handle. All right, so now we're getting close. I have some type issues here. Let's look at 4860. I have that defined. So we're doing an 8-bit mask. Let's see if masking that as 8-bit works. It does. We're missing a shift now, so we have to multiply this by 2. Or this is a set of pairs. The shift works. No, and yeah, that is the reason that what's being loaded is a signed 16, which is why, or sorry, an unsigned 16, which is why I had originally typed this as an unsigned 16, and that gives you the shift for free, which is another indicator that this is a signed 16. But then we miss the mask. So let me cast this as an unsigned 8. And does that give us the mask? And it does. And that gives us all the remaining masks as well. So some of the registers are off still, but everything else looks good. Now all the offsets above are correct as well. Some immediate values. There's a missing variable somewhere along the way, which may or may not be an issue. And so now we only have a few things left to work out. This looks like the comparison probably is inverted. Just the fields. Okay, I'm not gonna worry about it. So I was wrong about VARS2. VARS2 is a slightly different structure. It has, it's a collection of 16-bit values. Similar, but not quite the same. So let me make something similar but different. And so we need this to still be a 16 or 8-byte structure. And VARS2 will be this. And compile. And that means 40 needs to be that as well. Nothing epic yet. We're getting close to one of the helper methods for inventory management in the shop. It's not actually as juicy as I was hoping. All right, so there's a few things still down here. Oh, this is loading the item. Oh, duh. Drat. This might be the same thing. Shoot. I was wrong. Those were the same type. I don't need a different inventory type. I just screwed up looking at the offsets. All right, so let's see what else is wrong-ish with so the item code is being masked. Nope, this unknown field is being masked. Double and is not mask. So definitely not going to be a Commodore 64 port. Oh, I am just. Ooh! No, this is bad and wrong. Bad, wrong. These are two different structures because unknown 0 for the inventory item that's coming from the overlay is a byte, and we're writing it to a unsigned 16. So these do have to be different types. Okay, so sorry. Background and what's happening. What is going on here? So the long library was imported earlier this week. Mozilla pointed out that the inventory for the library was at a particular offset. And so yesterday I started looking at that a little bit towards the end of the stream. And there's only one function that uses that library or the shop inventory, which is this function here. And then there's one entity which calls this function. And it turned out that Alexander Sharon had already decompiled that other function, which is the, as far as I could tell, is the shop entity function. And I don't think that he knew what it was based on his comment in Git, but maybe he did. Who knows? I think he chose it because it was the longest function. And it is a doozy. But I think for the PSP, except for one variable, that this is done. And so this should be able to take this over to the PlayStation. And before I paste that, I do need these updated types. And we'll cross our fingers hold on to your butts. And we'll see if this matches. The function has not even close. The main issue with ugh. So the main issue with this function is that it's implemented as a irregular switch, and that means that the code that gets generated looks like a bunch of conditional statements instead of a jump table. And often we can write this in a way that works, but when you decompile it using M2C on the PlayStation side, you just get the conditional statements, and on the PSP side you get the switch. Yeah, I do think the DS is a reasonable target. I was gonna try to do some work on it before saying it, but there's actually, if there is a port of Soten to odd hardware, I have an idea for one that may not be challenging, but would be like the most cursed port, I think. And it's based on, if you go look at what Igarashi was working on, you could probably figure out what what I want to do. Oh, this is so gross. So gross. So we can go down from the top and see. So a few things that have happened here that I'm going to fix again. I started with the PlayStation version of this function because that's what I like to start with, and usually the decompilation is a bit better. But then, what did I agree? The way that the control structure was written was so different from the PSP version that I decided to decompile based on the PSP version. And that may or may not have been a mistake. I'm not sure yet. There's just some odd things in here. So even the top, we have a check for castle flags, and then you're going to increment, but that's not the way that it's written in PlayStation Land. All right. So we have some magic here. Thank you, Mozilla. So we have a category, an unlock level, an item number. Let's look at the item numbers. Actually, it would be fun to look at the data and compare that and just make sure it is what we think it is. And I'll do that a little bit, and then that's where we'll end. I think I'm going to take the PlayStation. The data is the same on the PlayStation and the PSP, as far as I can tell. The nice thing about the PlayStation, is it nice? I was going to say it's nice that it's already broken up into bytes, but I actually think the PSP version might, is it a little nicer? So for bytes, getting this little endian byte order is nice. But then for the bigger numbers, having the normal big endian byte order is nice. I can't decide. Let's look at it again. So based on Mozilla's list, we're going to have Jewel of Open and then Potion. Let's just take the first couple and we'll decode those and we'll do the first two. And see what this looks like. So I'm taking the little endian byte order. And so we have byte and then byte. And then we have an item code. In this case, the item code is zeros. So we can leave it like that. The order doesn't matter. And now for the last number, I'm actually going to grab it from the big endian byte order because that is a 32-bit value. And so 1F4 is 500, as both Eldritch and Mozilla have said. So now what we need is, this is Jewel of Open. So let's go to the item list and see what Jewel of Open is. So Jewel of Open in the relic list is, I think, too far down. Let me look at this again. So we have our item ID is 0. Actually, we have an items header file. We don't have Jewel of Open there, so let's look at the next one is Potion. And yes, 9F does correspond with Potion, which is the next item. And the price for the potion is $320. Which is 800, which makes sense. So yeah, that order makes sense. What is item 0? Item 0 is empty hand. So why would Jewel of Open be given item ID of empty hand? That may be a mystery. So it looks like chat might be broken on screen. So let me try refreshing that. Mozilla is saying this is the data that's used for the randomizer, so it's most likely correct, and I don't doubt that. Nearby. Oh, the category ignores the ID. Oh, that's interesting as well. And that's somewhat what we see in that switch, which okay, so what I'm going to do is I'm going to rename these fields. So and Mozilla has sent me a basically the enum value list as well. 0 being hand, 1 head, 2 body. So really appreciate all this data. So we're going to call unknown 0 category. And this will break everything. which is fine. I'm going to call that category in this alternate structure as well, because that is what it's being saved to. And now I have to find all my unknown zeros, and it should be safe to replace those all with category. And then unknown 1 is unlock level. Oh, that's interesting. And for that, now this is making more sense. And also why this structure is written, or why the switch is written in the order that it is written in, makes sense. So looking again at this switch and not treating this as item code at all, we're going to change item code here to item ID, because that matches what we call it other places in the game. And then item code, the item code variable will be called unlock level. And now let's read this again. So this seems somewhat broken logic, not terribly important, but we fall down to this case. So if we're at the highest level, 255, we're going to set the unlock level to 0. That means I'm guessing everything is unlocked. Then we have some additional game flags that are checked, and I'll have to pull what those are maybe tomorrow. And depending on if those are set or not, we might put the unlock level back up to 255. Otherwise, we're going to fall all the way down, and we're going to subtract 128 from the unlock level. If it's anything below. So basically 85 and up are kind of special cased. Yeah, you're right. It might be unlocked flags, because it looks like the top bit is something special and being hit by all of these. So we have 80 through 88. Not quite all of them. So minus 129. So then we have we're doing a lookup of a couple different things. We'll have to see what those are. So Mats is saying it might have a different ID based on what the category is or if it's wearable. Yes, and so I'll do a little more research, look at your notes, and then look at some of this as well. And I might pull this data and decompile the data. So your slot, no, not slot allocation, your, what did you call it? Categories match the item slot, it looks like. Not quite exactly. There is 0, 1, 2, 3, Oh, no, they're different. That's weird that these are different. So we have... Oh, because we have 2 hands in the default item slot, enum. And so this is an inventory or store item category. Okay. I think that's where I'm going to leave it today. I am going to move this over to the PlayStation side one more time. I might have to do a separate decomp for the PlayStation version based on what is available there. It is... I'm surprised that these are so different, but there might just be 1 or 2 little things that are throwing the optimizer off. And once those are resolved, maybe it will work out. It could be, for example, the order of the cases. Or any number of things. But the PlayStation side, not very decompiled. The PSP side, almost perfect. Just register issues, and it looks like there's a variable missing, which should be straightforward to solve. But we can look at that again tomorrow. So if you are just tuning in, I don't have any stats. My Twitch stats are down, so I don't know who's watching. But if you want to know more about what we're doing here, we're decompiling Castlevania Symphony of the Night. We're looking at the store inventory and some functions around that, trying to figure out what they do and what they're for. You can go to soten.z.dev to learn more about the Symphony of the Night decompilation project and join us on Discord. Really appreciate Eldritch and Mozilla showing up and giving a hand on some of the stuff that they've known deep in their hearts for a very long time. Appreciate all the work that you guys have done on the randomizer and all the data that you have already figured out what it is and that we're just learning about. So yeah, go to soten.z.dev. I'll be back tomorrow doing more decompilation, and that's all I have for you. Adios.